In today's video, we will be connecting NEPI RBX driver-supported robotic control systems to edge compute hardware running NEPI engine AI and automation software. NEPI's RBX driver abstraction layer provides a plug-and-play integration and a common API interface for all connected robotic control systems, regardless of their native interface, making setup, control, feedback, and automation processes easy to build, maintain, and reuse across all type of solution platforms. For this tutorial, I will be using an off-the-shelf embedded GPU processor box with the NEPI engine software installed and a quadcopter drone with PIXOC, PX4, and a NEPI IDX supported 2D camera. With your NEPI device powered on, open the NEPI device's RUI interface and navigate to the RUI Sensors and Nav Pose tab. In the Input Settings pane, select the Sync System Clock to Nav button if you want to sync your NEPI device's clock to the ArduPilot GPS clock value. Then select the RBX driver-produced nav orientation and heading sources you want to connect to NEPI's Nav Pose solution. If you don't have a GPS with a satellite fix, your latitude and longitude will be 0. Wait until NavPose output data starts displaying and updating from the PIXOC module. You can save these settings by going to the NEPI RUI System Admin tab and clicking on the Save button. RBX drivers publish an image that overlays an important status and process information on top of the robot's main camera image stream, or a black image if no camera is available. This image is published on the RBX topic, your NEPI device base name, ArduPilot RBX status image. An example would be NEPI S2X ArduPilot RBX status image. You can view this status overlay image using the NEPI Image Viewer application by opening the RUI Applications and Image Viewer tab and selecting the status image from one of the drop-down boxes. All RBX drivers support a common set of ROS status, settings, and command control topics that provide a complete set of tools for monitoring and controlling the ArduPilot through NEPI automation scripts. For details on the supported RBX ArduPilot drivers, ROS command control interfaces, and example ArduPilot automation scripts, see the NEPI Engine ArduPilot Control Systems Interfacing Guide at nepi.com/documentation. While the RUI provides a convenient user interface to configure and test your robotic control system, all of the data and controls we have covered have documented back-end API interfaces for automation programming and interfacing to other connected systems. To learn more about these interfaces, see the NEPI Engine Local System Interfacing and NEPI Engine Hardware Interfacing documents available on the NEPI website. Hopefully, this gives you an idea of how NEPI simplifies connecting and configuring robotic control system devices for AI and automation solution development.